Alrighty, I'm tired. It's currently 1:50 a.m., but I'm making this video for you. Alright, polygons in the plane. That's basically talking about fancy shapes. Okay? Okay. A polygon is a plane figure composed of segments and endpoints and blah blah blah. The endpoints are called vertices, and that's the singular plural version of a vertex, and blah 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 blah. You don't care about the vocabulary, I know you don't. But oh well, here we go. So, polygon is a fancy shape, and vertices are the plural form, like the more than one form of vertex, okay? The segments, you know, basically, when you have a shape, those things are called sides, yes, and then those shapes are composed of angles, you know what those are. And then the two sides that share a vertex are called adjacent, and then the diagonal of a polygon. Okay, so a diagonal of a polygon is a segment whose endpoints are non-consecutive vertices. Basically, if you have a shape like this, a diagonal would be... Oh, did you notice I'm wearing my hat like T.I.? Anyways. If you have a square... don't mind my square, it looks kind of crappy, but oh well. You see the... Yes? Okay, perfect. Let me label it A, B, C, D. Alrighty. A, B, C, D. A and B are adjacent. A and C are adjacent. A and D are not adjacent. Therefore, that would be considered a diagonal. If you have a pentagon, I can't draw pentagons to save my life, but I drew a crappy one. Oh well. Anyways, you have A, B, C, D, E. A, B, C, D, E. A and B congruent. I'm sorry. A and B adjacent. A and E conjacent. What is wrong? I don't know. I'm tired. Anyways, A and B, A and E adjacent. B and C, B and A adjacent. All these are not all of them, but the ones that are right next to each other, right next to the one in the middle, would be adjacent to that one in the middle. So you choose one that's not in the middle, and then you consider that a diagonal. I said a lot of words, but this is basically what it means. A and C can be considered a diagonal. D and A can be considered a diagonal. B and D, E and C, what else? B and E can be considered a diagonal. And I just drew a star with a pentagon around it. Isn't that a symbolic of something that society calls bad? I don't know. Anyways, so we have a pentagon here. A and D, those are diagonals. A and E, diagonals. I'm sorry, that's a C. A and C, diagonal. B and E, diagonal. B and D, diagonal. C and E, diagonal. C and A, diagonal. And I pretty much labeled all the diagonals. Okay. Get the gist? You get the gist. Love it. Saw one of my locks. Anyways, done with that explanation. Ooh, favorite ones because it's the easiest one. Perimeter and area. Perimeter. Perimeter is a fancy word that means add up all the sides. Okay? So if we have a square, it means add up all the four sides of that square. And that's your perimeter. If you have a rectangle, add up all the four sides of the rectangle. Bam. You got your perimeter. If you have a polygon that's like so many sides, just add up all the numbers of the sides. The sides are just the numbers on the outside, okay? So if I have a shape like this, and we have A, B, C, D, F, G, H, I. So if you have a shape like this that we don't know the name of, you just add up all the sides. This is A through I, so all I'm going to do is just simply A plus B plus C plus dot 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 all the way to plus I. And that is called perimeter. Okay? Add up all these sides. You have A plus B plus C plus dot dot dot. That's all of these because I didn't feel like writing all those. Plus I is perimeter. Okay? Now, area. There are specific formulas that I will give to you in a later video, or you can just scroll down to the bottom of this, what's it called? not this video because you're on YouTube, but if you go to my classroom that you're watching this on, you can go all the way down to the bottom. There says formulas. It should be in this corner, I believe, or this corner. I don't know my sides, especially not at 2 a.m. in the morning. But one of these sides, you'll find formulas. They have specific areas for specific shapes. Okay, cool. And what else? A three-sided polygon is called a triangle. I have to do this just because. A four-sided polygon is a quadrilateral. 5-side is a pentagon. 6-side hexagon. 7-side septagon. 8-side octagon. 9-side nonagon. 10-side decagon. 11-side, there is no 11-side. 12-side is a dodecagon. And and they have a thing called an n-gon. That means basically if you don't know how many sides there are and you don't feel like counting all of them, or like for example, if you have like an 18-sided thing, that's just considered an n-gon, and then you just plug in 18 for the formula to calculate the area or whatever they ask you for. Okay, cool. You don't need that. You don't need that. You don't need that either. An apothem. That's a fancy word that basically means it's like radius, but a radius is for a circle. Okay. I look like weird with one eye bigger than the other because I'm tired. But oh well. An apothem is basically the radius of a shape that has a center, but is going to connect to a side, compared to like a circle in which the radius connects to the side and they're all the same. Let me draw one for you. If we have a pentagon. Oh my god, I can't draw a pentagon. Scratch that pentagon. Okay, still a bad pentagon, but oh well. Compared to that circle. Alright, look children. Let's bring you closer. This is a circle. That is a pentagon, I think. You see how this looks like this, but this is a circle? This is considered a radius. This is considered an apothem. It's a fancy word that basically is the same thing as a radius, but different, because an apothem connects to a flat side compared to a circle, which is typically just for a circle. Okay? Okay. Consider that. Did perimeter, did area. Number of diagonals. Oh, if they ever ask you how many diagonals are in this shape, because it's an n-gon or whatever the hell, you basically use this formula here, which is you take that number of sides on that shape. Let's say it's a 14-sided shape. 14 times 14 minus 3. 14 minus 3, children, should be 11. 14 times 11 should give you 154. And 154 divided by 2 should give you 77, I believe. Check my math, children. 154 divided by 2. 7, 14, 1, 4. Yes, I'm the shiznit. Anyways. That's how you find the something or other of the diagonal, the number of diagonals within a polygon. Alright, cool. And then you have the angle sum formula, and then that's it. You don't need to know that other one because nobody cares about that one. Alright, angle sum formula is quite simple. The angle sum formula tells you the sum of the interior angles of any polygon. So that'll be this formula here. N minus 2 N minus 2 times 180 degrees. This formula here, okay? So, let's say we were talking about that 14-sided shape, and we want to find the number of interior angles. What is 14 minus 2, children? 14 minus 2 should be 12. 180 times 12. I don't know that off the top of my head, but I will find out. 2 times 0 should be 0. 2 times 8 is 16. Carry the 1. 2 times 1 is 2. Plus 1 is 3. 1 times everything, just bring it down. And you should have 0, 8, 1. Bring down everything. 0, 6, 11, 2. And yes, so on a 14-sided shape, the degree measure the interior degree measure should be 2,160 degrees. And that concludes polygons in the plane.